Um, okay, so thank you everyone for joining us this morning. So a 9 a.m. slot, so well done for organising your time appropriately. So I'm very, very glad to start this emergent session. And so many of us who try to promote open science sometimes find out that there are kind of institutional barriers, or there might be we're working within the kind of traditional academic system. But in many cases, there can be additional problems with trying to share software, trying to share data, and trying to present your results. And so in these closed environments, this is essentially what we're looking at in this talk. So thinking about how we try and adopt and follow open science practices when we're working with commercial interests, when we're working in government agencies, and so on. So delighted to have a list of great speakers today. And so we have in person, we have Grana Pobrick, and so oh wait a second, what's happened here? So we have Grana Pobrick. So Grana is a senior lecturer in the University of Manchester. Grana originally did her BA in neuroscience in Toronto, and then after that did a BSc in psychology at Belgrade, I believe, before going on to Trieste to CISA to carry out her PhD in cognitive neuroscience there. Grana has carried out a number of studies using brain stimulation techniques, and has been using that both to try and understand the function of different brain regions, but also brain networks, but also looking at potential rehabilitation techniques in different clinical disorders. And so as part of this process, as I'm sure we're going to find out, has received funding from various government agencies, and so has been working within those constraints. We also have here Professor David Kennedy. So David is a professor of psychiatry at Massachusetts Medical School, is director of the Division of Neuroinformatics at the Child and Adolescent Neurodevelopment Initiative, CANDI there, and was a co-founder of the Center of Morphometric Analysis at Massachusetts General Hospital. He's played a key role in MRI-based morphometric analyses, functional MRI, and diffusion tensor analyses as well, and has been a core member really of OHBM, and in particular the Open Science SIG throughout its years. And so we're delighted to have David here. We do also plan to have Professor Peter Fox, and I will give him a formal introduction when we work out the technical challenges of getting him to join there. But I'm going to hand over directly to Gorana, and so I'm going to just pull up some slides here.
Thank you, Neil. Thanks for such a great introduction. It's great to be here. I just told David this is the very first time I'm attending the HBM, and it's been a great time all over. So let's talk a bit about open science. So I've proposed this symposium, and I said it's as open as possible and as close as necessary. And then David, rightfully so, said, why is it revisited? And it is revisited because I didn't put it in quotation marks. This is not my title. This is the official statement of the Horizon 2020, which is the European Agency for Science. And their statement in open science is that it should be as open as possible and as closed as necessary. So I wanted to see how open and closed can this be in practice. So today I will present a study we've done in the UK and working with the government agencies. So this was a study funded by the MOD and their scientific branch called DSTL. This was a commissioned study, so they wanted to look at the behavioral effects and neural mechanisms of visual search training combined with non-invasive brain stimulation. So what I do in my daily life is mostly non-invasive brain stimulation. So we were interested here is, will brain stimulation do something over and above training itself? So as I said, DSTL commissioned another company that then had a subdivision called Human Social Science Research Capability that commissioned University of Manchester. And then University of Manchester said, well, does anyone do brain stimulation? And then I wrote a proposal amongst other universities, and we got selected to do a study. Now, this was just before COVID, so we had some delays, but in principle, so we were interested in carrying out a visual search training with and without TDCS. So I cannot tell you a lot about the findings, unfortunately, because I need to ask for permission to do that. But I can tell you about what we did. So obviously we had 3 groups. There was an active group, there was a sham group, and the control group. They all had, the active and the sham group had HD TDCS, and the control group just had training. Now, each participant had an MRI scan. Then we did pre-training EEG with the resting state and tasks. Then they had 5 days of visual search training, and then we did the post-training EEG with the resting state as well. Now we recruited 110 participants. They were tested 8 times over 13 days, and bearing in mind how huge this project was, the attrition was really minimal. We completed 880 sessions in less than 6 months because this is a commercial project. So there are very tight deadlines. So we started November 22, finished by April 23. So every participant had an MRI scan, then they had EEG resting state, then they did EEG tasks, and there were several tasks that we did. Then we did eye tracking with EEG as well, 5 days of training with eye tracking, and then post EEG with eye tracking on several behavioral tasks. So now we get to the point of open science, really. So what can I tell you and what not? So what are the challenges here for the open science? And what is the positive thing here? So we've talked to them about pre-registration, and they said, oh, well, that's great. Let's just do it. So everything I've told you so far, it's in the public domain, so I can tell you about it. So we've pre-registered the study, and we said what we are going to do. So that's great. So now there are some challenges, and the list is a little bit longer, and I'll go through the severity. I think I've ordered them in that particular order. So this was MOD project, and I'm bound by the Official Secrets Act, which I didn't sign, which is a good thing. But nevertheless, every member of my team had to have security clearance. And this has some data implications because only people with security clearance can have access to data. Now, this is the very first time I've done a project like this. It's extremely bureaucratic because these agencies have this principle of one size fits all. So I believe if I worked on the nuclear submarine and a study like this, something that we do in our daily lives, I think the principle is the same. We have to go through the same steps. There is a lot of micromanagement, which means that every 2 weeks we had meetings where they were monitoring our progress. We had to report on how well we are doing every 2 weeks. There are some ethical issues, so we had to go through military ethics procedure, which is very difficult, but that's not the point. It is sufficient to run the project, but it is not sufficient to reuse the data. And then I think the biggest problem here, and I think this is the crux of the problem, that we have a complete misalignment of goals. For DSTL, the endpoint was a technical report. So we had to write something about whether TDCS makes people better at a certain task. This was a part of a cognitive enhancement bit. And from me, for academic side, for us, when we get the data, we only then start thinking about it. We feel the data, and then we start, well, this is where the science really starts. I can do this, and I have resting state here, and I have resting state there. I could do technical things about it, but actually, that was not in the ethics. So this is now a huge pile of data that we are kind of struggling to think what to do with it. I can write at least 2 years of papers out of this, but we should think how to do this. And part of it is that nobody really plans the life beyond the project. We didn't plan the life beyond the project because we were so busy collecting data within 6 months. This was just a heroic mission from the entire team. For them, they had one task and they moved on. So in a way, they also see that we have now a lot of data, but hey, the funds are gone. And finally, there are some IP issues, and these issues are about the data and the output. So they own the data, and every single output, be it a paper, be it a conference presentation, is de facto theirs. So they first have to vet it, whether it's good enough and whether it's adequate. And then they can reuse that, regardless of who created the slides or who wrote the paper. Now, what would be the solution? There are no easy solutions here because this is a government project and they do not subscribe to the Creative Commons licensing. In the best case scenario, we could put the most restrictive Creative Commons licensing where we could share but give attribute to who did the science, that it could be shared for non-commercial purposes only, and the data cannot be modified, so we could not have derivatives. And this was kind of possible before, but it is not possible now. So this is the scheme that I found on the internet, and I have to give the copyright acknowledgement of this as well. This is how government security classification policy works in the UK. So before 2014, there were several layers of what was unclassified, protected, restricted, and confidential. And after 2014, this all got blended into this official thing. So the boundaries are now very, very blurred. And only last night, when I was kind of preparing, like, what am I going to say today? I thought about what official really means. And in a way, it means that I was self-censoring myself, saying, like, can I really say this? And this is where this plays a very important part. So what I'm actually here proposing is that we kind of all think, what would be a solution? Should we argue for a policy change for something that is maybe unclassified? These were civilian participants. There's mostly participants from University of Manchester. Or not? Shall we argue with the government that this should stay as is? Nevertheless, I think this was a great project, and it wouldn't have been done without an amazing team of postdocs and research assistants, 6 months, 880 sessions. This was absolutely heroic. We also had the technical partner from DSTL who was embedded into the team, so we taught him some EEG and MRI as well. And of course, the funders. I mean, all the funding got from DSTL and the HSSRC. With that, I would like to thank you and open the floor for discussion.
Okay, so I'm just going to bring in David Kennedy next. I'm very glad to say that we also have Peter, who's joined us online as well. So I'll do a formal introduction of Peter in just a bit. So, so if I just set this up and then pass this over to you, David, because it will show up on the screen. Thank you. So, David Kennedy.
Is this one on? Okay, great, thanks. So thank you for the opportunity. I thought, oh, what am I going to say today? So I've been thinking about that since the invitation, a few months ago. I'm at the University of Massachusetts Chan Medical School. I have kind of 3 jobs. I say by morning, I work on child psychiatry and clinical applications in child development, in autism and ADHD and other sort of behavioral dysregulation studies. In the afternoon, I work with a project called NITRIC, the Neuroimaging Informatics Tools and Resources Clearinghouse. It's it's been supporting open science since 2006, or the new version of that. It's been supporting open science since before the OSR was even born. So it's a data and software clearinghouse trying to make sure everyone is aware of all the resources that are available. And by evening, we work on a project called ReproNIM, the Center for Reproducible Neuroimaging Computation, trying to support the community in executing, improving the level of reproducibility that pervades all of our scientific studies. So those 3 mandates that I've been working on sort of follow through many years and have touched upon a lot of sharing issues. NITRIC itself is a data sharing resource. NITRIC is also a software sharing resource. So we hit sort of on the edge of all of these sort of sharing mandates and things. NITRIC lets the user solve their own problems. So NITRIC doesn't tell you how to do things. NITRIC lets the end user decide how they have to interpret the open and closed mandates. So for my story today, I wanted to dig in a little bit on the as closed as necessary part to discuss some thoughts on this closure topic. Now again, we could be talking about software, which has some different topics and details than on the data side. And again, I think from the recent mandates and kind of following on the prior talk, we'll sort of stay on the data, principally on the data side of this conversation. And ultimately, closure is a technique that we're using in principle for protection. If there were no protection necessary, we could pretty much leave things as open as possible and not really discuss this much longer, and the session will be done and we go to club night. But it's this closure and the issues of protection, particularly around data and the subjects thereof, that are driving a lot of these policy issues. So the first level of what are we protecting people from, it's protection from harm. When we have data resources, a disclosure of something from my data record could inadvertently disclose who I am. And so if who I am is disclosed, that could be an issue. More importantly is if there's a disclosure of something about me. So if I inadvertently disclose my diagnosis or my years of cocaine use, and I disclose who I am, that can cause harm in my daily life, and we don't want that kind of thing to happen. On the other hand, we do want to disclose my cocaine use and my diagnosis and things like that, not disclose to the world, but disclose in the scientific context of an anonymous person. Subjects 3894GZQ can have a certain amount of diagnosis and cocaine use because we want that, because that's the study, the science we want to do with the shared data. So it's not that we don't want that information out there, we just cannot let that be connected to the breach of the who these people are, because then that is where the harm comes from. The other thing that's pushes a lot of the policy towards the closure is protecting people from the harm that can come from discovery of things about my data record. My data record may not say I will develop Alzheimer's disease, but scientific processes that look at my data may come up with a prediction that, oh, I have a 97% chance of developing Alzheimer's disease in the future. That is something that the database doesn't have itself, but can be discovered from my database. So now if I disclose my, lose my disclosure of my identity, and these predictive things that can come from the database, I again can get into a place that can cause harm. Insurance companies might decide to have a high risk if I end up being identified as a person who has a high risk of developing some disorder. On the other hand, there's some discovery things are not necessarily all bad. Sometimes discovering that I have a high chance of Alzheimer's disease may make me able to prepare better, may make my family able to prepare better, may make me a different type of candidate for different types of studies. So again, it's not all harm, but there is potential harm that comes out of the disclosure and discovery of things that these are predictive of. And in the grand scheme of things, we really want our data to be predictive. I want someone to discover what my possibility of Alzheimer's is, because because that's why we collect these data, so that we can develop better interventions and treatments and things like that. So again, we want that discovery to happen, but we don't want that disclosure or the connection of that information to the individual subjects. And the third thing I'm not going to talk about is more sort of on the genetic side of things, is, if data breaches and loss of information can, especially in genetic studies, permit the discovery of things about other people who weren't part of the study. So if I have some chance of Alzheimer's disease, and you can find my third cousin once removed, there may be some disclosure about them who wasn't even part of the study. We're not going to talk about that one here, but those are the types of harms that are important, but they're coupled with we want to do these things, but the things we want to do are hugely hampered by the harm that can come from disclosure of who those individuals are. The other piece I want to say a touch about is for the data, we are usually talking about, in this case, human participants, and these human participants are motivated to take part of our study in the first place. People didn't just wake up in the morning and say, hey, well, maybe people do wake up in the morning and say, hey, I just want to do science. But when they're approached with a particular study, they ask themselves, do I want to participate? And you can ask subjects, why they participated, and you'll get, different types of answers. Now, this isn't a scientific study, and I can't cite, where this is from, so maybe someday I'll actually research how to cite this properly. But anyway, people often in general types of studies, perhaps UK Biobank, participate because they generally want to bring benefit to society. It's not really so much about them, but they value participation in study as a good thing for science to benefit society. Other types of motivations come from particularly targeted studies of different disorders and things, and people who participate often want to get specific benefits for people like me, other people with Alzheimer's disease, other people with cocaine addiction or whatever. So they're trying to participate with the expectation that these are being used to improve treatment, discovery, outcome, etc. Similarly, I think if you ask the people who are participating what they're most concerned about, they are concerned about these disclosure harms that we talked about, and those are fairly common and fairly obvious. But the other thing people often are worried about is profiteering. I don't want some big drug company to make billions of dollars off my 3 days I spent doing this, or 5 days in your study that I spent doing this study. It can be hard on me to do. And I'm happy to do it for other people like me, but if someone's going to make a lot of money, I would really rather not have that happen, especially if they're going to then develop something and charge me $1 billion to even take one dose of it. I just don't, and they're going to make a lot of money. Anyway, so this concern about profits makes us immediately think about companies, and once we get concerned about companies, that's the kind of thing that really gets us to this knee-jerk reaction to commercial restrictions on my data. And this story is also true in the software side of things. I don't want, Siemens, to benefit from my, diffusion processing thing because they can sell it for a lot of money. So these are why the default sort of urge from software developers and the way we guide, our subjects in their consenting is to really restrict, commercial use. I think you mentioned that as well in the prior thing. Okay. This kind of default feeling about restrictions on commercial use, I just got called into a concern about from a meeting I was at recently at the Michael J. Fox Foundation, a foundation that works a lot in the area of Parkinson's disease. This was a meeting that had people from academia and from industry and funders and foundations, and we were discussing and looking at the state of the art of MRI biomarkers for Parkinson's disease. A number of industry folks, were at the table, pharma industry, and they were lamenting, across the board, the lack of this data, the data that is driving the academic leads, that they're then going to invest huge amounts of money in, either the monitoring, types of things from the biomarkers or the biochemical marker leads, that come from academia are really driving, the types of things that they look at. And so because of these commercial restrictions and their lack of access to the data that's driving their discovery markers or driving their monitoring, they find that the roadblock to their tasks of bringing us validated, approved drugs are these commercial restrictions. We know that bringing an actual intervention to market is very expensive. In part, it's expensive because we don't necessarily do a great job in reproducibility and give bad leads, but even a good lead is very expensive to bring to market, and most don't make it. So we have this conflict. We want our data to help people like me. We don't want anyone to make a huge profit, but it actually takes a huge profit to cover all the leads and to get through FDA, through ethics, through the appropriate phased trials to actually bring an intervention to the market that will actually help people like me. So again, ultimately, I'm working my way to just bringing back to our attention this sort of knee-jerk, avoid commercial permissions at all costs. In software, if you want your software if you have some cool neuromyelin thing that you can look at the substantia nigra of patients with Parkinson's disease, well, someone's going to have to do that in a clinical trial. It's going to have to be FDA software approved eventually. So our adding of commercial restrictions can actually get in the way of making the software useful. Subjects who get sort of coached because of our fear of commercial to avoid commercial use of their data can really get us into a situation where we're just adding some barriers to the ability to solve the question we're most concerned about, is how to improve health outcomes with people like me. So the goal here is just to make sure that, not to make everything commercially available, but at least to get away from the sort of knee-jerk, thou shalt not do anything commercial because someone's going to make a bunch of money and therefore that's bad for me, is probably not the best way to think about things, and just want to make sure that we keep that in mind. And shameless plug for some open postdoc sessions.
Yeah, and yeah, thank you very much, David. Yeah, it's interesting to consider this balance that we have, especially when we're thinking about the long-term outcomes of what we're trying to do here. So I'm very glad to say that also we have Professor Peter Fox, who's joining us online. If I bring you to the main stage here. So Professor Peter Fox is a neurologist and neuroscientist at San Antonio, Texas. He started off his medical training at Georgetown, where he did his MD in medicine, followed by training at Duke University and Barnes Hospital. He was a postdoctoral fellow. He carried out a postdoctoral fellowship at WashU before becoming the director of the University of Texas Health Science Center in San Antonio, Texas. Peter's been a pioneer in the use of PET imaging initially, and then subsequently functional MRI. He helped build and improve tools for meta-analysis, but has also carried out substantial translational research projects and a whole host of clinically focused neuroimaging studies there. He's a founder member of OHBM, and we're delighted to have you online today. So if I hand over to you, Peter.
Okay, let me share my screen and is that sharing or not yet?
If you want to try again now, so I've made you a co-host, so it should be that you can.
Do you see my whole screen yet or not?
It's not coming up here yet. Can you share file instead of screen?
I can. So email you the file or share slides. I'm seeing, say, share video, share screen, share slides.
Share slides. The joy of hybrid sessions is always tempered against the technical challenges. But yeah, it's definitely good to see you at OHBM again, Peter.
Looks like it's coming through.
Perfect.
still slow.
I guess the backup could be if you want to talk through. No, here we go. Perfect.
Okay.
Yeah, we can see that.
Okay, so to start, I appreciate the opportunity to talk about this. I admire David greatly, and I completely disagree with his spin on this. So just to start there, in terms of what we're protecting and why we hold things back from open commercial use. I'm going to be talking about the BrainMap database, which has been sharing data for the past 30 years, a little bit more than 30 years. As was said, I'm at the UT Health Science Center in San Antonio at the Research Imaging Institute. And so what drives in the US data sharing policy and commercialization and their interface are two things. One is the Bayh-Dole Act, and this took place actually just before I finished medical school and started residency. And what this did was that it changed the law. So prior to the Bayh-Dole Act, all federally funded work went to the funding agency, the DoD, the NIH, the VA. They owned it. And they collected a lot of patent rights and copyrights, or patents and copyrights, which they never exercised or commercialized. So this was a huge sink of intellectual property that was going nowhere. And so the Bayh-Dole Act said, this is a big waste. We're funding the university, but we're gathering the IP, and it's a dead end. And so they put the universities in charge and said that all university research funded through federal funding was now the property of the institution, the data, any patents, any copyrights that could come from it, and that they were encouraged to commercialize it. And the reason is quite explicit. It's because if data and IP inventions are not copyrighted or patented, they will not be commercialized. That is because if you make something openly free, if anyone can get at it, one company spends a lot of time bringing it to market, and the others all grab it and compete with them in the same marketplace. So there's no motivation to use anything that's distributed free to bring a benefit to a patient. That will not happen. So the more we make our data open, the less it will help people. It will help scientists, but it will not help patients. It will not become a medical product, a medical software, a medical device. That won't happen. So the reason to restrict data, to say not for commercial use, is because the universities want to license it to the companies, not give it to them for free, right? Given the opportunity, companies will scrape data like mad. AI just scraped the entire inventory of the New York Times, right? So we protect our data so it doesn't get scraped and commercialized by somebody that's bringing no benefit to the university, no money coming to the investigators, but as well, if everybody can scrape it, then everybody's using the same data and there's no market advantage, right? So that's the intent of the Bayh-Dole Act. It's really quite explicit. And so following that, the NIH developed a research tool dissemination policy. And this took a while to develop. There was a lot of to and fro, and it became finalized a good while after the Bayh-Dole Act. But basically it says that they encourage sharing resource tools amongst universities, but not to be against the spirit of the Bayh-Dole Act. That is in no way to impede commercialization. So really, the NIH, the federal government at large, is protecting inventions and data, tools to make them more commercial and to bring them to patients. That's the point. It's actually written quite explicitly that if it's not protected, it won't be commercialized. Okay, so how did I get into this and why BrainMap, right? So this is me in 1983, gathering data. The scanner you see behind you was actually created by the spin-off company of the laboratory director, Michel Terpagosian. And so he was inventing things for PET imaging. This is PET 6. It was not the 6th generation, but more or less. And it was owned by his company, and it was in the university for us to do research on. He went on to commercialize this. This research funded by the Department of Energy is why we have PET. So all throughout this work, investigators are coming in and using technology that was being patented by a university employee that was then licensed to him, and he created a spin-off company and he brought PET to market. Okay, so this was the environment that I was trained in, where it was really just openly acknowledged that they could make images, but they didn't know how to analyze them. They really had no idea about how to turn these into data. And so the subtraction images on the right are with those goggles. In the PET scan, really big signal. And so the question is, how do we make data out of it? And to the degree possible, how do we share the data? So about copyright law. So we're going to be publishing this data. So what's the law allow and what does it not allow? So publishing in journals is great. The data that we were acquiring, nobody else in the world could acquire, and nobody else had software to analyze it. So sharing the raw data at that point didn't really make any sense. And even figuring out how to transfer that data around was pretty onerous. So if we publish it, prose is copyrighted, figures are copyrighted, data are facts and they can't be copyrighted. So if I could report the data in a way that could be reused and could be openly taken, then I could be putting out data that other people could reuse. So that's tabular data. Tabular data is free for reuse. If it's in a database, it can be copyrighted, but the data published in journals is free for reuse, right? So that was the motivation for publishing data like this. So it was a framework, a reporting framework of XYZ coordinates that TAILOR Act was already using and was publishing intraoperative stimulation within coordinates. And so the goal was to bring the data into the same framework that was already used in publications and make it available so that people could harvest this. And as we did multiple studies and other people started to be able to do this in other laboratories, all of it could be pooled and made a common resource that the journals couldn't stop us. They couldn't say, no, that's our data, which they could with anything else that was in the literature. So that was the goal. And so to make that happen, we began holding meetings. This was the first one with a lot of people you know there, with Bruce Rosen, with John Mazziota, with Art Toga, with Alan Evans, Leslie Ungerleider's in the back. So we all came together and talked about how to do this. And that became the BrainMap database. So if you want to make this something that you can hold on to and not have companies scrape, you have to copyright it, right? And to copyright it, you have to have a metadata schema which adds conceptual content to it. Otherwise, it's not copyrightable. And so a metadata schema was developed, and all the data has been encoded according to this schema since it started. So jump forward 30 years. So now we have databases with task activation, with voxel-based morphometry, with voxel-based physiology, which is PET, SPECT, ALK, REHO, and we have a pipeline of analytic tools. All of this is copyrighted, but it's free for people to use, but it's not free for companies to use, right? So anybody can go online and use this data, but they can't reproduce it, and commercial use is forbidden. So the goal of that is, as we move this forward and make patentable products with it, which is ongoing, that those can be protected and marketed and come to market and help people. So one of the latest things that is out there now, we just opened it up this time last year, is the BrainMap community portal. And so this has all the data, all the tools, developers' tools as well. And we're adding into it primary data for validation of models developed meta-analytically. So this kind of pipeline is in place where you can use the BrainMap databases to create node models, to do connectomic modeling, and then develop edges. So make complete models, validate it in primary data, and then roll this out to plan surgery, to target neuromodulation, to stage and monitor disease, to make diagnoses. So this pipeline is out there. The way the intellectual property works for this is that the data and the software are copyrighted, but the products that are created by the investigators using it are theirs. So they can patent them and copyright them and then have their institutions commercialize them. So the architecture is patented. A number of products that have already been developed are patented. And that's it. So this is really a kind of a different spin and a different approach, but that's where it came from. It came from understanding copyright law and the US laws regarding data and research tool commercialization. And I'll stop there. Thanks for your attention.
Thank you very much, Peter. So if people do have questions, please do come up to the mic and ask. Yeah, I'll start off with one. So I guess for many researchers, some of this will be completely new, and finding out about these tensions will be something that they perhaps haven't needed to consider. They might think, but actually it's perhaps just working in a kind of naive way of hoping that you put the data out there and you're going to that's going to be sufficient for GDPR law, international law, and for kind of best use cases. How do you think we should there be a shift in training in getting neuroimaging researchers to think more deeply at a broader level about these challenges of commercial versus public interest and so on? So to Gorana.
Like all great stories, even my story began at a conference. And I was talking to a very distinguished professor from the US who worked for years for DARPA. And I said, look, I'm sitting on a pile of data. I'm sitting on the pile of data and there is not a lot I can do about it. What do I do about this? And he goes, oh, just tell them that you're going to make it public. And I did. I asked, I was very naive. I'm naive. I said, well, how about we make this data public? And of course, the answer was no. But I now learned my lesson. And the lesson is that we need to start from the very beginning. We need to be very clear. Who owns the data? What can we do about it? Can it be used, reused, in what form, for what purposes, and then go on from there on. But there has to be training. I really went into this very naively, thinking, oh, this is an amazing piece of research. I'll never have this opportunity. I'll have all this data, and now what? I have the data, and I've written a technical report. That was the end goal. I gave them a recommendation. They accepted my recommendation. It was well received. But there is so much more you can do about it. And yes, here we are.
So I'll jump in to agree with the yes, we need more training. One anecdote, just even on licensing, it is so poorly trained on. People don't understand it. It's too complex for simple programmers and developers to come up with. The first 500 software resources that were listed at NITRIC back in the old days had about 498 different licenses. Universities were very protective of their specific licensing, and so that was a Wild West. It is much better now with Creative Commons types of, clicking. But even that, end users don't, particularly know exactly what the trade-offs are. And again, I think Peter's example is a good place of the trade-off of that. So education of the software, developers, and education of, the data hosters and the subject. And I keep coming back to wanting the participant to be part of this. The participant, at some level, is the owner of the data. We may have cast that away sometimes. We may be people who are holding the data for the subject, but keeping the subject and the subject's interests, given all the constraints and complexities of commercialization, et cetera, they have to, we have to figure out how to also engage the participant.
And Peter, is this something that you do in your institution now with new trainees, with new researchers coming through, or how's the training kind of integrated in San Antonio?
So actually, in the lab meetings, I regularly talk about what research is going on and what's being commercialized and what's not. And there's a knowledge among the trainees as to what the limitations are about their work if they get involved in something that's being commercialized. And so I've had a number of trainees whose dissertation work was embargoed before publication because it was submitted for a patent. But they're aware of that, and so that's something that goes on steadily. And so I work with them and teach them how to file invention reports. And so that's pretty openly discussed.
Yeah. We have a question from the floor as well.
Oh, yeah. I was curious if there is anything we can do, like at the level of, let's say, at the stage that I think is really relevant for this is ethics approval. So like Garana mentioned that we should go back to the beginning. So would you have done anything differently if you knew that the data usage would be that restricted? Because I think it changes the protocol. Like, so if you know in advance that you can do only so much with the data, then probably you wouldn't have included certain conditions or so I guess this is something that can be also done on small scale, like to make it part of the ethics protocol, like, yeah.
Yeah. So the way we do it now, we go back to MODREC, their ethics, and we ask for amendments. Every single time we want to do something with the data, we say, well, can we now do this? And then wise men sit there and they think, well, how sensitive is this? And then they say yes or no. They mostly say yes. I would also like to say that there are colleagues. So these are the people who work at universities and who are member of the scientific committees of the ethics committee. And then they understand the amount of data that we have, that something can be done with this. So I had a very positive response, but it's a very long procedure to go every single time through amendments. And the project has finished. So once the project is finished, for them, it's like, well, I'm just keeping this ethics open as much as I can in order to see what can be done. Something that David said as well, participants are really important. So we asked our participants, because this was really like, they had to come to the lab 8 times. They had to do MRI and EEG. These are all very long sessions, very long trainings. Why are you doing this? And interestingly enough, money was not an issue. They said, we are going to get an MRI scan, which we promised. So that was in the ethics. So in the ethics, we said that every participant can get an MRI scan if they want to. And the only reason everybody came is, can you get me an MRI scan? I said, yes, that's their data, and we gave them this. So that was a positive thing. So because I was really afraid I will never recruit 110 participants and scan them and do all of these things within less than 6 months. So what I would have done differently is, yes, write different ethics. And then you're covered. This was a project-specific thing.
Peter.
Yeah, so there's another strategy that can be implemented that we've been doing for a long time, and it's at the large lab level, so at the center level. So I've held for about 30 years a repository consent, and this is a separate IRB that I hold and just keep renewing. And whenever an imaging study is done in our lab, so many people use the lab, but they understand and are informed that the repository consent will be offered to everyone. What the individual investigator needs and does and how they store their data is one thing. But if they sign the repository consent, it goes into the Imaging Institute's XNAT archive. And we've learned over time what things to put in there. And DICOM images have the date of scan embedded in the data. So we've had to add into the consent form that you'll allow the date of your scan to be known, right? So there's little things that the archivists learn that the individual investigators don't learn. But what this means is that we have a huge data resource that can be shared very openly, and it's independent of the funder. It's used for all funders, DoD, VA, NIH. So we use the same repository archive. So this makes very large data sets available with not that much trouble for the investigator.
Can I just, one, thank you for that, and two, also point to something called open brain consent. So there are places that are trying to aggregate, this the type of consent paperwork you deal with. Again, getting back to sort of these check marks, you have to deal with GDP or not, or you have the commercial thing or not, whatever. So all these things are just trying to lower the barrier to being resources for subjects, for studies to get access to consent forms. The other thing I wanted to add, again, researchers who often, not to blame researchers, but their primary job is to get the grant and to get the study done and to get the papers published. Often their first task is to get through ethics. I just got to get through ethics. I'm not necessarily thinking about, the long-term things. I need to get my progress report done. I need to get my papers published. What's the minimum I can do to get through ethics? And I understand the pressures to do that are strong, but that's, again, where we need to keep thinking about the patient and what's the right thing to do in the end.
Yeah, I think that's a good point. So I've worked in institutions where they have, had this repository approach, and then others where you suggest it and people are scared, and they're scared of indemnity, they're scared of the ethics boards themselves, and maybe that's where sharing knowledge and trying to promote that as a best practice across institutions would help to bring down that fear barrier. So I think that's us coming up to 10 o'clock now. So I'd like to thank the speakers on stage and online for actually a really fascinating kind of insight into the challenges of why we collect our data and what we do with it once we have it, but also thinking about software as well. So hopefully this is something that we can actually keep going in future years, because it is an important point that does apply to all neuroimaging researchers, if not more broader. So thank you very much, Gorana, David, and Peter. Thank you. Peter, if you could just stay online for a second. We're just going to take a quick photo with you in the background.